Alright, hey guys, my name's Calvin and
Tim.
so we decided to do a little beat detection project, pretty standard, but there are multiple ways to skin a cat, and we tried to do something a little bit different than the analog filters that a lot of people are doing. We tried to implement a lot of those digitally. This is the overall schematic. Over here we had a simple electric microphone from Radio Shack, a little bit of biasing over here to make sure an input was in the right area. The interesting part of this amplifier is that it's non-inverting, but this capacitor right here, if you actually go through the frequency analysis, what it does is it makes sure that there's a 0 dB gain for very low frequencies, like DC. So essentially what that means is that the bias here, DC, is the same as the bias here, DC. It actually worked pretty well. That was a huge challenge at first because we didn't realize that without the right capacitor value, it would just throw everything off and make your amplifier rail regardless of any input. So we thought we were getting a DC output for a sine wave input when we were testing. That was driving us nuts. Then we passed it off to an ADC, which actually wish was a little bit faster. That definitely slowed down our design. And then these right here are our digital filters that we implemented. We have a bandpass filter, which is supposed to filter out mostly the percussive and the low frequency sounds, so make the bass thumping. Then we have a low pass filter in order to get rid of some higher frequency noise that would be imposed on our signal. And finally we have a bandpass filter to roughly select the beats per minute that we anticipate our songs are going to run at. So potentially you could take this to like a music festival and actually make some improvements and hopefully have some LEDs flashing on your body as the music changes.
Here's kind of the core parts of our code. All of this is inside of a loop, but we start off by getting the sample from the ADC, and then we run it through the 3 filters that Calvin talked about, the 2 band passes, and then the low pass. And then we have some threshold that you can tune to say that once the beat is greater than that threshold, then you turn the LED on. And lastly, this is just what one of the digital filters look like. All the samples are running through float arrays, and then there are some multiplier values that the new value will be calculated from. And then demo.
Yeah, to be clear, a lot of these digital filters that we found were actually referenced from an online source of a project that did something really similar, because there's no way that we could do this on our own. We just don't have enough DSP experience. So we could probably provide a link in our report.
Yeah.
Those are essentially just derivative filters.
The base one.
You're just looking for a certain derivative on your frequency.
Not the base one. But the low pass, I think the low pass is basically finding the envelope of your signal.
Originally, you wanted to do something with like pulse width modulation, so that there wasn't just some like arbitrary threshold that the LEDs would turn on, but we realized that using the onboard timer along with the ADC introduced some noise into our analog input, so that was no.
We were getting 2.5 volt spikes periodically at 1 kilohertz.
So it's gonna light up here, and then you just have some music or just sound coming in from anywhere, and then once the mic detects it.
I like to break it down. This joint has got me open. Ooh, that's my favorite song. I put my thing in motion. I do it all night long.
And then it just, that's it. Okay. Okay. That's it.
Thanks.